Hi, this is Isra Hussain from Superior University, Lahore. Hope you people are doing well. Today we are going to have a brief discussion regarding AMOS. In previous session, we have PLS, STATA, and SPSS videos as well, in which uh, we learned how to conduct analysis on this software. Today we are having a new software to use. We shall have a brief introduction with AMOS, and later we shall also learn how to conduct analysis while using AMOS software. Uh, why we feel the need of AMOS software? As we can say in the previous sessions, uh, as we discussed, that if we want to explore the theory, then we use the SEM, and if we want to test the theory, then we shall use CBSEM. As we want to test the theory, we shall use CBSEM. For this purpose, we shall use MOS software. There are some sort of rules of CBSEM. Before going to illustrate some kind of rule, some sort of rules, let me tell you, MOS is basically a statistical software, and it stands for analysis of movement structures. AMOS is an added SPSS module, and this is uh, specially used for structural equation models, path analysis, and confirmatory factor analysis. It also known as analysis of covariance or causal modeling software. Causal effect, as you know, causal. That's why it is known as causal modeling software. AMOS is also a visual program for structural equationing model SEM. In most, we can draw models graphically using the simple drawing tools. As you can see on the most left side, there are some kind of tools. And most quickly performs the computation of SEM and display the results. In the calculation of SAM coefficients, most use the following methods: maximum likelihood, underweight least square, generalized least square, Brown's asymptotically distribution free criterion, scale free least square, and you can you also know that if dependent and independent variables are too many, we shall use MOS. If we want to compare the theories, and there are there are there are two steps of SAM in AMOS: build the measurement model, test the model, and in the measurement model we shall uh, model and discriminate. We shall check the measurement model and discriminant validity, and conversion validity as well. In conversion validity, we check the factor loadings in previous session. In discriminant validity, we use HTMT ratios and PLSM as formulaic criteria. In MOS, we cannot check the HTMT ratios. In MOS, we use only formulaic criteria to check the validity, because in MOS there does not exist HTMT ratios. We shall also check the ground goodness of fit in MOS. On the basis of the theory, we shall analyze the data. Either theory is confirming the result of the collected data. Is that theory confirming or rejected? So as you can see, this is the main screen of AMOS. When you will click on AMOS icon, you will see this screen as well. First of all, we shall draw our latent variable, and with the passage of time, as the lecture will go on, I will have a brief introduction regarding these variables. This is latent variable. As you can see, you can also draw observed variables, and here you can draw observed variable. So you can hold a variable. If you want to hold a variable, you can use this hand. If you want to give the title to some kind of variable, you can give them titles, and this is known as moving object. As truck shape is, you can see, and you can see move of different objects, variables, and their factors as well. Here this is showing a floppy disk, which means if you want to save your diagram, you can also save it. You can zoom it, zoom in, zoom out, and this you can save. You can also print this diagram as well. You can undo or redo as it is showing. You can apply Bayesian model, Bayesian here. Let's start our today lecture regarding, as you can see, this is showing latent variable. What we will do, we shall simply click and draw here. As you can see, this is shown here in the screen. I have draw a latent variable, and after this I will also draw another as well if I want to draw. And after this, if I draw again, I can draw it again, as you can see. And after this, if I am having more variables, I can draw another as well, right? Okay. uh, and after this, if I want to rotate them, I can also rotate them. As you can see here, rotate them, indicators of latent variables. What I will do, simply I will let, I can move this anywhere where I wish to assign this latent variable. As you can see, I have moved, right? And after this, you can also give them title, name to these variables, and you can also uh, create a connection of these variables with other variables as well. As you can see, all these four variables I have put it over here, as you can see. And these are main variable. We shall give them name, and these square form are the factors, or you can say elements of the objects, and these small round circles are error term. We can, as you know, we have error terms in every model, as previously in other equation models we were having error term. Without error term, we cannot have a main, you can say, a model. Uh, this is also a very big difference in equation and model, because in model there is included error term, but in equation the error term is not included. So first of all, we shall learn how to copy data file in AMOS software. So first of all, here we can see select a data file. What you need to do, you can simply click over here, and you can uh, find out the file name on, or the path where you have given this file. As I am having this file on my desktop, and with the name of, you can say, sample test for practice. I will select and I will open here, and it will be simply open the file. And after that, you will click on OK, and this will copy the variable over here, as this is showing the list of variables over here. You can copy the data, and you can have all the variable list as well. And you can give name to all these variable. What you need to do, simply you can right click over here, and you can rename this object as well, uh, according to your wish. As here variable name portion is given, let's say if I want to check the give it name according to my model or design of dissertation diagram. So we can write B brand loyalty is known as BL. I have given it BL name as BL. After that, I will click on the other one, and I can also give it name as service quality as SQ. And after that, I will give name this element as this object as well. As you can see, purchase intentions as 3I purchase intentions, right? And after that, I can give this also a name, or in other words, you can say advertisement, let's say. And after that, what you can do, you can open this list file and you can give step by step drag and drop. You can give them name as I am having all these variables element names here. Okay, and after that we are having another variable which is known as EPI, and we shall give them name EPI and, three. And after this, you can also give this name as well. Okay, as you can see, I have given all the names to the elements according to my. Please remember one thing in your mind when you are drawing a measurement model. You have no need to be worried about the dependent and independent variables, mediating or moderating variables. You can use all these structural variables wherever you want, or these variables according to your wish. But when you are going to discuss structural equation model, at that time we shall have a need to draw our model in a proper way according to our dissertation writing. We shall use a proper model by using the mediating and moderating variables according to our structural equation model. As you can see here, these small circles, you can give name to them as well. For this purpose, we shall click on plugin, and after that here you can see name unobserved variable. We shall click on it. This will automatically give them name as arrow term 1 2 3 4 5 1 2 3 4 5 according to model. So after this we will go further for next step. Now what we shall do, we shall create links correlation between all these four variables. As you can see on the most left side, there is double-headed arrows. We shall select this double-headed arrow, and we shall connect one to second, then one to third, and then 1, 2, 4. Same like that, we shall draw from second to third, from second to fourth, and same like that, we shall draw third to fourth as well. Okay, as you can see this shape as shown on your screen, we can connect all these variables by choosing a double-headed arrow. After that, as you can see, this drawing is not looking good, as you can see. So what we can do, we can use a magic stick known as touch of a variable. We have given this stick a name, magic stick. So we will click on the variables, it will automatically adjust all the links as it is not previously looking good. Now it's looking very good, and we shall click the other one as it is showing also good, then again the third one. Now it comes in a proper shape, as you can see by using the magic stick. So guys, next now we can save, as we have made this model, we can save it. Here you can see a floppy disk. By clicking on it, uh, you can save your model as well. As I have clicked, and it was already saved, and it has been saved now. uh, After this, what we need to do, after saving the file, we shall click on analysis property here, as it is showing that analysis properties. So we shall click on this icon, and here you can see it is showing minimization history, standardized estimate. We can select all these uh, analysis, and after that you can close the window. After closing the window, you can also click on the calculate estimate to run the estimation, and after when you will click, this will be highlighted as well. As